Hello everyone and welcome to this new video tutorial. Today we are going to learn about rules and norms of the schematic diagrams. This means diagrams that you draw on electronic. This topic is related to our subject called electronic drawing. We are going to learn some standard and basic rules. Let's begin with our first rule. The first rule says that you can only draw horizontal and vertical lines, just like this. Vertical and horizontal. These lines representing real-life wires that you use on electronic circuits, for example. So these are the one and only lines that you can use. The second rule is related to the first one, which states that you must avoid using oblique lines. Oblique lines, for those who don't know, are curves. Curves are this. You cannot do this while drawing schematic diagrams. These are not allowed. You cannot do this, neither this. Okay? While drawing, you must use lines. Okay, simple lines. You don't have to make them thicker. The third rule says, in any case of using oblique lines, all of those have to have the same angle of inclination. Let's say that you draw a curve, an oblique line, okay? And you're trying to finish the circuit, and you do this and this. Well, all of these curves must have the same angle of inclination in here. They have to be equal. You cannot do starting an oblique line like this and then doing something like this and finishing like this. It is not allowed. And this is just in extreme cases where you have to use those lines, but let's try not to use them. The fourth rule is really important because it says that if there is an electric contact on the lines, you use a node. What is a node? Well, a node is represented in electronic drawing as a point, a joint. Okay, this is a node. But how is this useful for us? Well, while drawing lines, you can see here there is nothing more than a cross section. Okay, they are touching each other. You don't know if there is no node. So that will help us to identify if the lines are touching, if the wires are connected, okay? So here, now you can know that the wires are touching each other. They are in electric contact because there is a node, okay? This is really important to identify. For example, in many cases, you will draw many lines. And to identify which of those are touching, you have to use nodes. They are really basic and really important as well. The fifth rule is related to the fourth, which says that if there is no electric contact, here there is no electric contact, you just draw like this, okay? You cross lines and that. There are many ways to draw when there is no electric contact as here. You can draw it like this. Okay, this is one way. Another way to draw the situation when there is no electric contact could be like this. Okay, the lines are just approaching the wire, but they're not touching. Okay, or simple by drawing the lines without a node. That's how you can express when the wires are not in electric contact.
So I'm going to explain the next rules for the circuit analysis stuff. So the first rule says that we have components that need to be connected to the ground. We are not going to do this. For example, here we have three components that need to be connected to the ground. And we make a node. And we draw the ground symbol and they are connected. That's incorrect. So in this case, the sixth rule says that for each component that needs to be connected to the ground, we need to draw the ground symbol for each of everyone of the components. So like this, and this is correct. This is incorrect. The seventh rule is a little obvious, but it's better to be remembered. It says that all the cables, components, and that stuff need to be ordinated. We don't want a mess. We want the people to know what is our circuit and be able to read it and know this function. For the next rule, we have variables. These are just letters. We are going to use a lot of components like R for resistance, C for capacitor, B is the integrated circuit, and D is the diode. Or in this case, it could be LEDs or RGB LEDs, color LEDs, or infrared sensors, in this case, or diodes. There are a lot of variables that we need to learn. These are the basic ones. It's better to know what letter we are going to use for each or every one. The next rule stands for every variable or component, we have to take a omega order. For example, we have two resistance here. We are not going to put R and R in both. We need to have a lot of order. For example, the 8th rule says that we need to number the components. For example, my resistance 1 and my resistance 2. And then the last rule that we're going to explain is that for each component has its value, or in this case its value. The resistance are measured in ohms. For example, we have R1, resistance 1, with a value of 330 ohms. So for each component that we are going to use, it should have, or it must have, its value raw here. If we don't have a space, we can draw the R1, and then we're going to make a list for in the end of the circuit, and we are going to put the values that is in extreme cases, and we came back for the other rule that we are going to draw it ordinated. So in that rule we can't make the space, so we can put the values in the component and don't make a list, and it is more easier to find it. So that's all for my part. My other partner is going to continue with the next rules. Thank you.
At least the next rule is for only the components. When you have a component like a CE, you cannot write all the name of the component like full other. That is so wrong. You should put only the code of the component, Like in this case, you should put U, F of full, and A of other. Unity, full, other. And this is the correct form. The next following row is for the flowcharts and the block diagrams. If in the block diagram you have a block, you should put the arrows in the middle of the block. That means if this is a process, you cannot put the arrows in the corners like this. That is wrong. So you should put the arrows in the middle of the block. That is mandatory. In this case, you can put in the sides of the block or on the top and down of the block, but always in the middle of the block. The next rule is if the component values don't fill well, you can create a table to assign the values to corresponding components. This means that if you have a complete circuit but a lot of components, you don't will have any space for put the values between the components. So that means that you can create a table of components and values. Here you can put the name of the component. In this case is R1, and you can put the value of the component. In this case, 5 ohms. The final rule is when you are drawing a circuit. Let's suppose that this is a circuit, and we have a component here. But if we see in these parts, we have intersections. And for any intersection, you must use nodes for differentiating it. So, if we have an intersection here, we should put a node. In this case, it's a point. And in the other part, you should put a node.
Okay, now that we have just finished showing you the rules of drawing schematic diagrams, we will test your knowledge by this exercise. You just have to identify the rules and norms that were applied on this draw of an circuit. Okay, for instance, you will write here we are using the rule number 5 because this and so on. Okay, this exercise will help you to identify the points where are needed and important while drawing. Okay, so try it and remember that getting better at electronic drawing is while practicing a lot and doing many draws. Okay, but always remembering the rules to follow. So that will be all for us, and thank you for watching the video. Please stay at school and see you in the next video.